Hello students, welcome to Mike Sword Academy. So today we are going to be looking at a question relating to the Gay-Lussac law, which is the pressure law. So we have two questions here that we are going to be solving. So question one, it says a fixed mass of gas has a pressure of 70 centimeter mercury at 30 degrees Celsius. Then calculate the pressure at 60 degrees Celsius, assuming that the volume is constant. Now, from our previous class, we said that the pressure law or the Gay-Lussac law is the point where we try to look at the relationship between pressure and temperature. So we saw that the pressure is directly proportional to the absolute temperature. So in that case, we can look at different states as we proved in the previous class that P1 over T1 will be equal to P2 over T2. So this is the initial state and this is the final state. So from the question, let's see what we have. So from the question, we are given the pressure of the gas. So P1 initial pressure was given as 70 centimeter mercury at a temperature, so the temperature is 30 degrees Celsius. Then we're also given the temperature, the final temperature at 60 degrees Celsius, and we are asked to calculate the final pressure. So we don't know the final pressure. Now we go direct to substitute and solve to get the answer, but there is a problem. Remember, the temperature we talked about is the absolute temperature. So that means the temperature should be in Kelvin. So how do we convert degrees Celsius to Kelvin? Very simple. We plus with 273. So if I plus with 273, I will convert it to Kelvin. So if you should point this in your calculator, this should be giving us 303 in Kelvin. Then we do the same thing for the next one, which is in degrees Celsius. We convert it to Kelvin by adding with 273. So if you do that addition, you'll be getting 333 Kelvin. So we have now converted to the absolute temperature. So we substitute, we are going to be having P1, which is 70 millimeter mercury, divided by T1, which is now 303, equal to P2, we are looking for, divided by T2, which is now 333. Now, if we cross multiply 333, we multiply with 70, we'll be having that P2 will be equal to 70 times 333. Then divide by 303. So we have 303. If you divide by that and punch in your calculator, this will give us, from the calculation, we have 76.93 now centimeter mercury. So that becomes the final pressure. We use centimeter mercury because P1 is also given in centimeter mercury. Now let's look at question 2. So in question 2, we are still looking at Gay-Lussac's law, where we have an air in a container was at 700 millimeter mercury. So the pressure here is 700 millimeter mercury at a temperature, so the initial temperature is 30 degrees Celsius. Now the temperature is raised to, so we have a new temperature as 50 degrees Celsius. Then what is the, when the container was placed in sunlight, what is the pressure of the container? So we are looking for P2, which is the final pressure. So we are going to use the Gay-Lussac's law, and as we used in the first question, so which we have as P1 all over T1, P2 all over T2. So if we should substitute, we are going to have P1 is 700, so we have 700 times, let's just divide with the formula. Then T1 is this. Remember, our temperature must be converted to Kelvin. So if I plus with 273, I also have to plus this one with 273. So if you should do that in your calculator, you are going to have that for the first one, will give us 303. So we'll be having 303 Kelvin. Then if we plus with this, we'll be having 323 Kelvin. So when you substitute, now our T1 is 303. So put 303 equal to P2. P2 we are looking for, so we don't know it. Then divide by the final temperature there, T2, which is 323. So we have 323. So I'll cross multiply, then make P2 the subject formula. 700 we multiply with 323, then divide by what? By 303. So if you punch this in your calculator, you will see that this will be giving us 746.20. Then what will be the units? You have to look at what your P1 is, millimeter mercury. So that means the answer should also be in millimeter mercury. So with this, we have been able to calculate the final pressure. So in the next class, we solve more problems that relate to the gas law. So if you are just joining the channel, do well to subscribe and also click the notification button. You'll be getting updates of different videos we'll be posting. Thank you.